Incretins and type 2 diabetes, discovering a new piece of the puzzle. In today's modern society, a dramatic increase in patients with type 2 diabetes indicates that an unchecked global epidemic is at hand. Pathophysiology, digestion and diabetes. Glucose is the basic fuel for the cells in the body and is provided, in part, through the process of digesting the foods we eat. During digestion, the hormone insulin is released by beta cells in the islets of Langerhans of the pancreas. Insulin acts as a cellular key, allowing the passage of glucose from the bloodstream into the cells of the body. In patients with type 2 diabetes, the amount of insulin produced by the beta cells is often insufficient. Another important hormone of the pancreas is called glucagon. Glucagon is synthesized and released by alpha cells, also located in the islets of Langerhans. When glucose levels are low and metabolic fuel is needed to avoid hypoglycemia, glucagon stimulates the liver to release glucose, which has been stored as glycogen. A closer look into the mechanisms that regulate beta cell production of insulin reveals that the ingestion of food causes the release of substances from the gastrointestinal tract. These substances include hormones called incretins. Two important incretins are glucose-dependent insulinotropic polypeptide, or GIP, which is released from K cells in the duodenum, and glucagon-like peptide 1, or GLP1, which is released from L cells in the ileum and colon. In the pancreas, both incretins have been shown to stimulate an insulin response from beta cells. Incretins in type 2 diabetes. It has been observed that the production of the incretin hormone GLP1 after a meal is reduced in patients with type 2 diabetes. Since GLP1 levels are reduced in persons with type 2 diabetes, the insulin-regulating effect on beta cell function may also be compromised. With GIP, however, the ability of beta cells to mount an insulin response is substantially reduced. Glucagon release from the alpha cells of the pancreas is suppressed by GLP1, thereby reducing hepatic glucose output. The incretin mechanism is highly glucose-dependent, as illustrated by a study where GLP1 was introduced in patients with type 2 diabetes. When glucose levels were high, GLP1 increased insulin. However, once blood glucose levels fell, insulin levels returned to baseline, thus demonstrating the unique glucose-dependent mechanism of incretins. Experimental data from animal and in vitro models suggests that incretins also stimulate insulin biosynthesis. These studies have shown an increase in the number of beta cells resulting from proliferation, while also showing a decrease in cell death, or apoptosis. These findings have not yet been confirmed in humans. DPP4, an enzyme that degrades incretins. Dipeptidyl peptidase 4, or DPP4, is an enzyme that degrades the incretins GLP1 and GIP. DPP4 exists in both membrane-bound form on the external surface of various cells and is also found throughout the plasma in soluble form. Most incretin breakdown by DPP4 is believed to occur in the capillaries which surround the incretin-producing cells in the intestine. Less than 2 minutes after GLP1 formation, DPP4 quickly degrades GLP1 by cleaving off 2 terminal amino acids. In a similar way, GIP is also rapidly degraded. The inhibition of DPP4. A possible solution to the rapid degradation of the incretins by DPP4 is through the administration of a DPP4 inhibitor. In clinical studies, DPP4 inhibition has been shown to increase levels of intact incretins, thus increasing insulin and decreasing glucagon. This resulted in improved glycemic control without increased risk of hypoglycemia or weight gain. The inhibition of DPP4 represents a promising new strategy for the treatment of type 2 diabetes.